The purpose of this is to give you a little bit of background to faults. There are different kinds of faults. I don't usually go into the specifics unless I'm talking strictly about those. So a fault is a break or crack in Earth's crust along which rocks shift their position. Describing a fault, we can use different ways. We can talk about a fault line, which is here at the surface. We can talk about a fault plane, which is like going down along that whole boundary. A footwall, which is here, and a hanging wall, which is here. So the hanging wall is typically the one that's going to be doing more of the movement. Okay, so we have normal faults. With normal faults, it'll essentially have one end going down, the other that's staying upwards. And normal, you'll notice that if this were to go upwards, it would make a cliff. So this is the part I want you to pay attention to. If it is a normal fault, this part's going down. It's not making that cliff above. But this doesn't look so much like a cliff as a big slide. So that's what we're talking about when we're talking about a normal fault. Normal faults often occur along divergent boundaries. Reverse faults or thrust faults. Here we have this would be our hanging wall is going upwards and causing that cliff type look. And then the other side is going down. That's going to happen more primarily and occur during a convergent boundary. And then the strike slip is more of your transform where one is going one way, the other is going the other way within the same plane. So they're not going up or down, they're just going horizontally. So here's our transform in San Andreas. And here's typically what we see for the types of faulting. Now I focus more on the divergent, convergent, and transform, but these are typically what we talk about when we're talking about the fault, the normal, the reverse, and the strike slip. So here we have some obvious pictures where we can tell that there is a fault. We've got this right here. You can see the separation of those layers where they change in the location of where they're at. Here we have the fault at a surface where we can kind of tell that there's a difference in that height of the ground. Here's another fault where, again, it's that difference in the color of the rock that makes it very evident that there's a fault. And here we've got another one. You can tell that this layer was at one point in the same level of this layer, and we've got the movement. And the rock layers definitely help us understand which way things are moving. Okay, so a fault zone is a region of numerous closely spaced faults. So like when we think of California, we primarily think of the San Andreas Fault, but there are way more faults than the San Andreas in California. A lot of them are just a lot smaller. We've got the San Jacinto Fault, the Elsinore Fault, and there's a whole bunch of other little ones that you'll be seeing with the assignment you're going to be working on. So what's happening in California, we've got the North American plate that is moving in this direction, and then we've got the Pacific plate that is moving in the opposite direction, and that's creating that transform boundary here. Now anywhere else on the plate, we've got some different boundaries, but the transform is what we're going to be focusing on. Here we can see all of the different earthquakes, and it's not just along one line because there are a whole lot of smaller faults in California. So you can see there's the magnitude change from the size of the box, and then there's the time frame. Now this is from 2009, this map is, so we have some from the past hour, the past day, and the past week based on the color. Will California break off and fall into the ocean? Well, based on the tectonic plates, it's showing that California is gradually going to move away, part of it, from the United States. Okay, and all of these little lines that you see are faults.